Domain 1, Task 4. Okay, this is a core skill in physical security. Asset identification and valuation. And we conduct an assessment to identify and quantify vulnerabilities of the organization. So let's get started on that. So collecting relevant data for your evaluation. So incident reports would be internal logs and external police records. Crime statistics would be from where your facility is located. That would be law enforcement bulletins. It could even be neighborhood watch or the neighborhood associations who sometimes have good crime statistics based on input from the police. And FBI data as well. Stakeholder interviews. Again, the people who know best about what the vulnerability is usually the stakeholder who is responsible for that part. And that's why we, last week we spoke a little bit about interviewing the security manager, and I think they are key. They're pretty much clued into things going on. They might even know their own vulnerabilities and they know what they need to look at. So having a good security manager and being able to talk to them on a one-on-one basis is very important. System logs, that could be access control logs, intrusion detection, video analytics. A lot of video analytics these days can give you quite good logs based on motion, direction of motion, and even identification of people versus vehicles versus something else. Direct observation. I think this is key to what I used to do. It's basically an on-foot walkthrough of the site. And just walk with the security manager, point things out, take a notebook with you or a tablet or whatever to write down information, take pictures. And direct observation is probably one of the best ways to collect data of a site or a facility. And benchmarking. This is basically lessons learned from other organizations, peer organizations of industry-specific threats. So that's important too. And very importantly, the survey should detail the current state compared to the desired state. And you should document weaknesses such as blind spots in cameras, policy gaps, and outdated technology.
Yeah, I will be adding the direct observation, for example. The good practice should be doing this in every time of the day, because it's not the same maybe during the day that at night. At night, you can have different different vulnerabilities, different kind of thing. If you are doing a site assessment, it should be good to do that in different time set.
Yes, that's a good point, because nighttime is totally different, and that will also reveal any inadequacies in lighting, any lighting, a dark alleyway or a dark passageway that's not well lit. So that's also very important, Nelson. Thank you. Okay, evaluating security measures. So the technologies and equipment typically that we have these days, access control systems. So the one thing you should evaluate here is the effectiveness of the readers and biometrics. Is there a fingerprint reader? Is there facial recognition access control that seems to be getting more popular? And also the door hardware, is that maglock strong enough for its purpose? Video surveillance, covered zones, retention compliance, 30, 60, 90 days. If it's retail, sometimes they go long-term, like a year for litigation, slip and fall litigation. But yeah, the retention, that's retention of data on your video management system, of course. And any integration with analytics, analytics like advanced motion detection, direction detection, that sort of thing. And also how current your cameras are and your video management system too. Alarm systems, accuracy, frequency of false alarms. That's really important because there's a false alarm rate or FAR that's part of some analysis, and you get to a point sometimes if a system gives off too many false alarms, the people who are supposed to be receiving these alarms kind of just tune it out. It happened actually, now that another story that I remember, actually at JFK Airport, there was a gentleman on a jet ski on the Long Island Sound who had too much to drink. He was on his jet ski, he got off, and he went up to the fence at JFK Airport and kind of just walked right over it or through it because the alarm system on the fence, I think it was a fiber-based system, was so falsely triggered so often by wind, by animals, by whatever, that they kind of just tuned it out. So it's very important to make sure your false alarm rate in an alarm system is not too high. Intercoms and duress buttons, their placement and accessibility, of course, and lighting, very important, both functional and deterrent. Lighting is one of the least expensive deterrents around. If something's lit up, it makes it a lot less of an inviting target. And make sure that the lighting corresponds to CPTED. Remember, crime prevention through environmental design we spoke about, where you deter crime by having a good layout with lights and open space. Security personnel, staffing levels and coverage, that should be adequate. Competency and training levels, of course, should be up to date. Response capabilities and situational readiness should also be something that's part of the equation. And the quality of the shift reports and communication, very important. Shift reports are done by the staff, and that should make sure that it's clear and concise and it gets acted on. And security procedures. Visitor contractor management. Some access control systems have day passes, temporary passes for visitors or contractors, incident response protocols, maintenance of security systems, and reporting escalation policy. That's all under the procedures. And for all of these, use, if possible, quantitative metrics, because this is important. This should have a number attached to it. And you can usually get that information from the logs of these systems and tell you that, or a false alarm, false alarm rate was very, very high, 80% or something like that. You can work that out, but try to use quantitative metrics. And things like patrol frequency, of course, is easy to count and log, and that would evaluate effectiveness objectively. Okay, interpreting technical documentation. This can be tough, and this looks a little, don't let this scare you, but this is basically, you should at least have an idea on how to interpret technical drawings to identify system gaps. So whether it's a blueprint on paper, which isn't too common these days, or a PDF, which is usually more common with current systems they have, but you should be able to at least look at site plans, building layout, perimeters, fencing, access roads, and even from a 2D sketch, be able to at least work out some vulnerabilities. Not saying that it will be the only way to do it. We should do that walkthrough. Floor plans, interior space, critical zones, egress paths, all that should be easily read from a document or a blueprint. Elevations will be camera sensor mounting, line of sight. Typically get a cone, an angle, a view of the camera drawn over the diagram if they're using the right software, and that can tell you if that camera is sufficient and gets you good line of sight. Riser diagrams, that's probably a little more on the technical side there, but that's just basically what goes up a riser that goes between floors, structured cabling, and subsystem interconnectivity. And hardware schedules, locks, readers, control panels, that sort of thing. Most of these plans are done on CAD systems these days, computer-aided design. So they can be just a PDF that you can look at on your computer and zoom in on parts that are a problem. Some systems, there's a kind of a PDF markup tool called Bluebeam that's very popular with consultants these days. It enables you to mark up a PDF, of course, digitally on your computer. And a lot of the other CAD systems these days also, in particular, Revit, R-E-V-I-T, is a 3D CAD system, which is really good for camera angles because you can spin that angle around and you can actually see from the camera's point of view what the camera sees. So those sorts of things are getting very advanced. But that's something else to keep in your head too. Feel comfortable looking at a blueprint or a diagram and trying to work out vulnerabilities. Very important, standards, codes, and compliance. These are some places to get many of the documents that you want. And there, if you look at ASIS Online, asisonline.org is the website, or ASIS. They give you a lot of very good documentation that if you're a member of ASIS, typically they're free. And there's some really good documents on things like NFPA. NFPA is the National Fire Protection. That's the numbers you want to be critical of course, are 730 and 731. That is for electronic security and premises. So NFPA 730 is the what, and 731 is the how of premises security. So that describes construction, protection, occupancy features, and practices. IBC building code, that's a requirement for egress and fire safety. OSHA, of course, worker safety, implications of security design. FEMA and DHS, risk management and critical infrastructure protection. And then, of course, United Facilities Criteria, UFC, which is a Department of Defense criteria, DoD. And of course, ensure compatibility and requirements for ADA are met. And as I mentioned, that could be things like door egress, card reader height for the reader itself, that sort of thing is in the ADA specification. So we can talk a little bit about the environmental and physical factors. So the facility location. We touched on this in a few slides back, but local crime trends and police response times. These are the things that shape security vulnerabilities. Proximity to any civil unrest zones, protest venues, or high-risk industries. Structural design, perimeter defenses, barriers, gates, bollards, entry points, doors, docks, and choke points too, points of congestion that may hinder response or facilitate attack. Very important. You can see choke points sometimes when the building shuts down for the day, and you can see people are rushing to one exit. Very important to take a look at that and make sure that there's no choke point that could cause a congestion during an evacuation. Lighting and surveillance. You should evaluate lighting levels and shadow areas at night. As Nelson mentioned before, do the walkthrough during the day if possible, and if you can do one at night as well when the lights go down. Look for coverage overlap with cameras. You may have to visit the control room, the security operations center, have a look at the camera angles, see what they're seeing, and ask the operator. Another way to do it is, ask the camera operator, and he will be your expert in that field, and he'll tell you what's lacking and what's happening. And verify emergency lighting and generator redundancy. That's under lighting and surveillance. Entrances and access control. There should be segregation of employee and visitor flows. Employees should have their own entrance just to keep things easy to read. And the presence of clear zones and natural surveillance areas, and integration with access control technologies and procedures. CPTED integration. So this is, of course, as we mentioned, crime prevention through environmental design. That should be used to deter intrusion through strategic design, enhance visibility, including your lighting, and territorial reinforcement. and design user-friendly and aesthetically integrated defenses.
Yeah, I think in the in domain 2, we will go in a little bit deep in crime prevention through environmental design. Is something that is really important at this moment. It's something that the PSP test will take in consideration, but it's covered more in deep in domain 2.
Yep. Yeah, so the way Nelson structured this, I like the way this is, because we kind of start in little bits and we expand as we go along. So if things aren't making too much sense right now, don't worry about it. I guarantee you by at least a couple domains down the road, you will be much clearer, and this will all make sense and come together. Okay, key outputs of a vulnerability assessment. This is a nice little handy chart to have. So the deliverable will be a vulnerability matrix. That would list identified weaknesses, assign likelihood and impact ratings to prioritize threats. A gap analysis report. That would be for disparities between the current security posture and the desired or standard. So what the customer really, really would like versus how it stands now, that difference is what you want to be working. Countermeasure recommendations. So specific actions to address vulnerabilities based on best practices, standards, and site needs. For the risk quantification deliverable, you would apply scoring or modeling to prioritize vulnerabilities and support decision-making and resource allocation. And your compliance checklist. Make sure all your codes, your OSHA, your HIPAA, your ADA, and internal policies are satisfied or flagged for correction. Make sure you're adhering to all of those regulations. So it is 10 after 7, and that is the end of domain 1, task 4. So if there's no questions that have arisen.
Well, thank you for being today here, and thank you for going with us in this study group, and we hope that help everybody, and see you next week.
Yep. See you next week.